So looking at number 10 on the vertical motion worksheet. A man standing on a bridge throws a rock upward. Okay, well, it's on the bridge. Throws a rock upward. 2 seconds later, the rock passes the man on the way down. And 3 seconds after that, it hits the water. So 3 seconds after that, so I'm just going to go ahead and call that t equals 5. And I guess we could label t equals 0 the starting point. So a man standing on a bridge throws a rock upward. 2 seconds later, passes the man on the way down. 3 seconds after that, it hits the water. Find the initial velocity and the height of the bridge above the water. Okay. You know what's interesting about this question is it doesn't specify feet or meters. So, Lauren, you asked the question. You want to work it in feet or meters? Feet it is. So negative 16t squared plus v0t plus s0. And we're looking for v0 and s0. So this is kind of tricky. Velocity then is negative 32t plus v0. Acceleration is negative 32, but that's not really going to help us. So we need to know some more things. What do we know at the top here? How do you know t is 1? It's halfway in between. Yeah, however long it takes to go up is how long it takes to come down. So that I think we can use right here. So v is 0 and t is 1. So now we know what v0 is. That was 32 feet per second. And we're trying to find S0. I think we could use this bottom point because when t equals 5, s equals 0. So 0 equals negative 16, 5 squared, plus v0, which we now know, times 5, plus s0. Calculator problem. So S0 equals 240 feet. So yeah, that was a good one because it had two unknowns and we had to use some extra stuff that it didn't really specify.
What is this after that? It means after the 2 seconds that it passed the bridge.
Yeah.
Not after the beginning.
Yes. After that, and that refers to that meaning when it passes the bridge on the way down.
How would you know that that's the height in between the bridge and the water?
2 divided by 2 is 1.
Because we're going to say this is S0, our starting point, and we're going to say the water is 0.
Okay.
Why did you plug in 5 if that seems so random? Like I would never do that.
Because I knew that down here, I knew that S was 0. I was trying to pick something that I knew. So I picked down here because I know S is 0 down there. If If I picked anywhere else, I don't think I could figure out what S0 is. Other questions from vertical motion? We haven't done much of that today.
Can we do 3? I know we kind of discussed it in class, but I was so confused.
Sure. Number 3. Suppose that a 5-foot chandelier falls from the 100-foot ceiling in the Capitol building. Okay, Capitol building is 100 feet tall. The chandelier is 5 feet, so it's a lovely chandelier there. And you are 6 feet tall, standing directly under the chandelier. How long do you have to get out of the way? Not long. So the question is, where do you want to call ground zero? That's the important part of this problem. And you could pick a couple different spots. I think I would say your head is ground zero. So I'm going to call that ground zero. What's S0 of the chandelier then? Like where is the chandelier starting?
-11.
100 minus 11. So I'm going to say S0 is 89. And know that when it gets to 0, so I've accounted for the 6, I've accounted for the 5. If I say S0 is 89, then the 5 and the 6 are kind of already accounted for, and I don't have to worry about those anymore. So S equals negative 16t squared plus V0t plus 89. Although V0 is going to, what's V0 going to be? 0. Presumably no one's throwing it at you. That would be extra cruel. It's bad enough that it's falling on you. Right, yes, it doesn't get ejected from the ceiling.
Can I ask a question?
Sure.
You didn't specify
Put a unit on it.
Don't answer the question at all.
Alright, so what was the question here? How long do you have to get out of the way? So down here at the bottom, S is 0, and we're trying to find time. T squared is 89 over 16. Square root of 89 over 16. So you have 2.358 seconds to get out of the way. That's plenty of time to get out of the way as long as you see it coming, I guess.
You don't see it coming.
If you don't see it coming, well then,
You look up and it's just...
yeah, it depends on where you see it in the process, how much time you have. Part B. If you do not duck or get out of the way, how fast will the chandelier be traveling when it hits you on the head?
Who made these questions?
It's cruel, isn't it? Let's see. So V is negative 32t. Well, just negative 32t because there wasn't a V0. So negative 32 times 2.358. And in fact, since I have it in the calculator, I can just hit times negative 32 to make sure I get accurate to 3 decimal places. Negative 75.472 feet per second for part B. Part C, if you were only 5 feet tall, how much greater would the speed of the chandelier be? So for part C, you got to redo the whole problem with S0 being 90, right? Yeah, rather than 89.
And then you have to like.
And then subtract, because it says what's the difference in velocities. That's kind of interesting if you're a foot shorter, because you would get more time,
But it was kind of faster.
but it would hit you going faster. So if you use the time to get out of the way, great. If you don't use the time to get out of the way, then it's going to hit you even faster. I suppose we could do this kind of quick since it's the same algorithm, same process. Square root of 90 over 16. 2.372 seconds. So you don't get a whole lot of extra time, that extra foot. Velocity would still be negative 32 times t. All good?
Yep.
Okay, nothing crazy?
Nope.
So not very much difference if you're 5 feet tall versus 6 feet tall. I guess we should answer the question. So 75.895 minus 75.472. 0.423 feet per second faster. But I guess that makes sense. If it's falling 89 feet versus 90 feet, that's not really a big difference. Get a little extra time to get out of the way, and if you don't, it hits you going a little bit faster.
Unless you're like 1 foot tall, then it'd be like a big difference.
Yeah, obviously if you were 90 feet tall, you wouldn't have much time, but it would barely hit you, so maybe you'd be okay. In addition to the other problems of being 90 feet tall.
So if it was like a giant